Okay, so welcome back. Let's go over some problems from chapter 2 that hopefully you did. So number 4, let's look back on number 4 on page 88. It says, the subshell that can be occupied by a maximum number of 10 electrons is which letter? And you should know that 10 electrons, okay, there are 2 electrons per orbital. So this is a subshell that has 5 orbitals. And which one is that? That is D. So it's letter A. Okay, what about number 9? Let's look at that. Chlorine is represented by the Lewis structure. Then it shows you the atom that would be represented by an identical electron dot arrangement, so by the same Lewis structure, is what element? And without even looking at the answer choices, you have to say to yourself, the Lewis dot structure shows me the valence electrons, so what other element will have the same type, the same number, and the same kind of valence electron? Any element in that group or that family of the periodic table. And the only correct answer there is B, which is fluorine, which is number 9. By the way, there's a little typo in the answer key. It says 19, but that is in fact not correct. The answer is 9, which it also says the answer is 9, but then in the answer key it says it's 19. So not true. What about number 12? It says, which element is the most active metal of this group? What are active metals, or what are active elements in general? Those are the elements that will easily either give up or receive electrons. So either really weak elements that easily lose their electrons, or very strong electronegative elements. But here we're talking about a metal, so we're not going to be talking about electronegative stuff. So here we want to think the opposite way. We want to say which element will easily give up its electrons, and thus it will be very easy for other elements to take it, so therefore it will be very reactive metal. And in this case it's actually potassium. It's C, number 12, because it's the one at the very bottom, so it's the fattest one, so it's the easiest one to pluck off the electron from. Okay, let's do number 15. Silicon with an atomic number of 14 will probably exhibit an oxidation number of +4 in a compound. All you have to do is find silicon at the periodic table, and when you look at the periodic table, what will its oxidation number be? It is right there in the middle along with carbon in that same family. So you can either gain 4 electrons to form an octet, or it can lose 4 electrons to form an octet as well. So could it exhibit a number of +4, and will it likely exhibit? Yes. These are the elements right at the center in the group with carbon and silicon and so on. Those ones can either gain or lose electrons, okay? And then the second part of the question says silicon is an element that has amphoteric properties. What are amphoteric properties? Amphoteric properties is when an element can either act as an acid or a base. So it can either lose or gain electrons. Okay? And this is precisely, silicon is this type of element. However, there's a third part to this question, right? We have to see if because makes sense. Does it make sense? It does not make sense here, because it is an amphoteric element. However, it's not because it has an oxidation number of 4. Okay? It's simply because it can either lose or gain electrons.